Right, we're on to a customer's repair, and it is a Rotel RVC220. So, let's see what it does. He's already bought a brand new mic for it, and it's come on channel 20. Now, if you looked at the last video with the Fidelity 1000, we were unable to do picture-in-picture because the link lead that goes between the secondary switcher and the main mixer got damaged because I trod on it. So there's a new one on order, but I can't show you picture-in-picture. So I'm not going to do any exotic sets which you've never seen before. We'll make sure that yesterday it was Fidelity 1000, we've done that a dozen times. We're doing the Rotel 220, Cybernet 134, you know, nothing out of the ordinary. We do have an out of the ordinary couple of sets, starting with that Midland 77104 GTL. So I'll tell you what, before we open it up, I'll tell you what figures we've got. So I've got the power supply on, the radio's drawing 290 milliamps, the meter's lit up, and these don't have PA, so not applicable, and the meter lamp works. So that's 2 boxes ticked. So I'm going to switch the test set to the 3 watt range and key up, and it's swung well beyond 3 watts. It's actually doing 3.4 watts on channel 20, and it's drawing 1.228 amps, which is what you'd expect. We'll pop that on channel 40, and it's doing 3.9 watts. That looks like it wants balancing better, and it's doing 4.4 watts on channel 1. Did I misread channel 20? Yeah, I did. It's doing 4.2. So it's not right. Low power, I think it's at the back on these. Yep, it's at the back. And low power is doing 40 milliwatts. Deviation, see where we are, but I'll test it. So the deviation meter isn't always accurate on this. Sometimes it is, sometimes it isn't, and we're using the test set behind me on the next bench back for verification. We'll just see what he's doing. Wallop. But it's actually exactly 2.4, which is ideal if that is the case. We'll come to the VCO, and the frequency now, we've only just switched on 79065. So it's a little bit low. We'll pull that up, and I'll do it right at the very end so the instruments have been on more than half an hour as is required. So the meter bangs across. So that's FSD for full scale deflection. So we'll now turn our attention to the receiver, and we'll put 2779065, exactly the same, in the signal generator instead of the correct frequency, so being absolutely fair. Switch the Cybernet meter on and plug in the instrument speaker. And for 12 dB Cybernet, well, this is excellent. It's doing 0.31 microvolts. For 10 dB, it's doing 0.26. And for 20, it's doing 0.68. That's so good. I'm just going to check my switches are in that position. They are. Okay, squelch threshold. Sorry, squelch tight. never opens. And threshold. .85. S meter putting 100 microwatts on the signal generator, so it's reading 6. So how much does it need to read 9? And the answer is 1 millivolt. So that's very lazy. The only switch works. We've got a bit of noise on the volume control. The only socket works. So here we go. Get the lids off. So really it will sound, and the way we're going to do this will probably not make much difference the way it performs on the air. So we've got to balance out the transmitter and just ensure that the receiver is as good as it's possible to be. Check there's nothing dodgy I can spot. I can't see any capacitors that are imminently likely to fail. We'll use one of Alan's kindly donated crocodile clip leads onto that earth strap. Get the multimeter out, which has got it wrapped around yet another video mixer. So we want channel 40. Far side of resistor 4, and we should have 4 volts plus or minus 0.1, and we have exactly that. So we're going to transmit, we should have the same again. Just pop that down to the merest fraction. So we don't know whether we have to turn it to the left or to the right, because it's random. Oh, it likes being there, doesn't it? Okay, back to receive, on to transmit, go to channel 1, should be between 1.8, 2.3-ish, we've got 2.22 on receive, we've got 2.27 on transmit, excellent. Once again not brought my clipboard. So we had 3.91, that stays the same, plus 4.15 plus 3.96. What's that done? So we're not going to have any channels dropping out, which is what happens if that's not right. So back onto channel 20. Turn the volume down so it doesn't annoy us. And let's see if we can peak this transmitter. So we have to go through the 3 coils here to try and get absolute maximum on channel 20. So we're currently at 4.5 and a bit. Could be 4.5 and a bit more. Arguably 4.6. So the idea is, it's not being. It's very important to say, it isn't being clever, making this do more watts than it's supposed to. Just like it's not clever making your car go in the wrong gear. legality aside, the radio has leeway so that it's on top of the job. Right, so these three now we peak. That feels broken. That feels broken. That is frustrating. This is what happens. Wrong tools used, broken cores. So pause the video while I unsolder them. Before I even get there, we've got another two boo-boos to correct. It's had both the driver and the output transistor changed. And this has had the leads left long. The trouble is, it's virtually the same height as the case. So that would only need a bash on the bottom whilst it's transmitting, and that would have shorted out. So that needed addressing. So we're going to take out this core, this coil and that coil, and hopefully find there's enough to turn round, because they're not easy to combine. To my knowledge, only Knights at Kirton and Lindsay actually have them for sale for about $150 each. I mean, these are 40-year-old sets and they're not a normal size by electronic standards. So I'll pause the video again. So we haven't got enough left. It's less than half, so it's alright as there's a chip out of it. But so I ordered these from Knights myself the other day. I've got some more teeny weeny screws for mic plugs. You know, this little one here, which go missing, I'd run out of them, and they do them for 25p each. So we ordered a quantity of those, and I ordered 3 of these cores while I was at it. I thought, well, they should last me, but I'm going to put 2 of them in this set, aren't I? Even so, if I can open the packet. Right, so we'll take one out. I'll load it onto my trimming tool and lose it in the radio. So I'll leave it just flush like that, and we'll put that coil back in. So now we'll move on to the next one. What I'm going to try and do is see if there's anything we can tap out. See whether we can remove it from underneath. Yeah, this one seems to be coming out from underneath. So it still hasn't got, even that bit's not full height, so again we're going to have to put another one in. So this is what the phantom screwdriver person does with the wrong tools. Right, we'll put that back in the radio. So I'm trying to hold it in with one finger and solder the other side. I unsoldered that inadvertently. There we go. I'll go over this with chemical cleaner later. So as a temporary measure, I'm going to put the bottom on because of the capacitive effect. Right, I'll power it back up. So now, because these are at a random point, I've now got 2 watts. So as I said before, we need to get this to maximum. So that's now peaked. 2.5 watts, 3 watts, change scales. So that's now peaked at 4.5, which is its absolute maximum. Now I'm just checking the others because they all have to be at maximum. You've got to be quick with this because it can't support this kind of power for long. So we're now at 4.7, 4.8 watts. That's maximum. So now I have to follow the service manual, and it doesn't matter how many times I do this, I forget. So it is 4 clockwise, that one clockwise, and 9 for anti-clockwise. So we've peaked all 3, so clockwise for 4.4 watts. That's there. And the green one anti-clockwise, the manual says for 3.8 watts. But we want the maximum legal limit. Unlike the manufacturer, we're not trying to get it through customs. So there we have it. So that was incredible. I knocked the volume control with the mic lead. Wouldn't do that if it was a fairground and win a prize. So we know we've now got 4 watts. So we'll just change it to channel 40. It's 3.9 watts. And we like these to be within 0.1, which that is. Did I say 4? I said 40. 3.9. And channel 1 is bang on 4. So that's quite a good outcome. Because often you find the top and bottom are going to be 0.1 away. I've seen them as bad as 0.2, but this one's jolly good. Sometimes they are always 4, but it's down to component tolerances. So that's that fixed. So now we want the meter to read on channel 20 4 watts because we're in dummy load. It reads 5. Meter preset is there. Remember, this is a relative power meter, so it only reads correctly into a dummy load. When it's on an arrow, you may key up and it reads 1. It might bang across the end stop. It still doesn't mean you're doing any different power. It'll still be 4 watts. It's just that the SWR of the aerial, etc., affects the reading. Right, so I just want to make sure the deviation is where I want it to be. Now this, is this in the central position? It is. It is where it's fine. So as long as it reads right on my other test set, then that's absolutely fine. Now this low power preset, as often as not, they're dirty. Sometimes we have to replace them. They're 100 ohms. I can't get 100 ohms. I have to put 200 in. That doesn't affect it. Just means it's setting up slightly different. So on low power, flick the switch. We may have a dirty switch. There we are, 400 milliwatts. Flick the switch, 4 watts, flick the switch, 400 milliwatts. So that's that done. Better go back to normal full power. So we'll move on to the receiver now. I'm switching my oscilloscope on because I want to do the detector. The detector's here, and we're looking for an S9 input signal. It's 100 microvolts. We're looking for maximum recovered audio on an oscilloscope that's just connected across the extension speaker terminals. That was absolutely spot on. I've made no difference. Now we're going to look at the Cybernet meter, and I'm going to put enough signal on to read about 4 dB. We'll go through the front end and then the IFs. So that first coil's made a bit of a difference. That's made no difference. You haven't got the extra coil on this model. Bit more signal with the IFs. That's it. Done. Now I'm going to read off, see what we've got. So for 12 dB, I've just discovered I was in the wrong scale when I took those. There should have been 0.82, 0.7 and 1.35. I thought it was pretty immaculate. So after tuning, and it's annoying when I can't show you pictures to what happened there. So let's have now have a look. For 12 dB, we've now got, actually we've got 0.8. For 12 dB, for 10 we've got 0.72, and for 20 we've got 1.3. There's actually no difference. That was me trying to be quick. Squelch threshold. So the book says these are about 0.75, something like that. So it's about where it's supposed to be. It's not outstanding, and it isn't rubbish either. It's just normal. We've had these outstanding ones, haven't we, with the extra circuits as well, like the Banatone 5-star recently. I've been spoilt. So when you buy the Rotel 230, it does have a better receive than the 220, and the Harvard 420M is usually one stage better again. Right, squelch. So I'm going to turn the squelch to full, and I want it to open when I twiddle this preset, which it does. Now I'm going to adjust the attenuator on the signal generator. 30 microvolts it's gone off, 100 microvolts it's come on. That's where we want it. While I've got 100 microvolts on, we'll do the meter, and you can see it reads about S6. So we'll adjust the meter for 9. That's interactive now with the squelch. We're going to have to twiddle that again. And recheck S9. So now we'll turn the squelch to minimum, put the signal generator to standby. I've parked it at 0.3 of a microvolt, comes back on. No, that's lousy. Let's try that again. Signal generator to standby. Signal generator back on. Okay, so we've got to this is the next day, we've got to the bottom of the squelch problem. I've actually ended up changing a dozen of the small value capacitors, like 3.3 microfarads, believing that the IF is being dragged down because of capacitors. So looking at this blow up of the circuit diagram, we've got the audio IC there, we've got the final parts of the previous stage there. I was looking at things like capacitor 78, 100 microfarads. There's one further on than that which I didn't blow up. So what I'm looking for is anything that was an electrolytic in and around the filters and the IF. So I've also changed the ceramic filter, and now we've got a squelch that works properly. So there's 1 microfarad, 1 microvolt. That's 0.3. So we can hear down to about 0.13 microvolts. The cyanide reading is once again changed. So we'll just go through that. So 12 dB is now 0.48 microvolts. Ten dB is 0.42, and 20 dB is 1. I'm going to change scales because I'm right on the edge between there. Yeah, it's not quite 1. Well, I could say 1.02 or something like that. We'll give it the benefit of the doubt and say it's 1 microvolt. So now, let's look where the squelch is. Turn the squelch up to full, and on the signal generator, I'm now going to put 3, 10, 30, 100 microvolts. So, just as I like it to be, 100 microvolts. Now, we set that before, and then I discovered it was like 2.5 microvolts to open the squelch. This is where I had to stop and look, and it was getting worse. So, as the set's been on overnight, which I left it on overnight, it was getting worse. So, it's got to be capacitors, and it was. But as a precaution, I've changed that filter as well. So let's look at that. So threshold, signal generator to standby. Switch the signal generator back on. It's parked at 0.3. It's nearly coming through at 0.3. We're going to give it a proper test. 0.3. 0.34. Naught 0.34 microvolts. So that figure was just the adjustment, but this whole circuit was getting worse and worse and worse. That just goes to show how it's important to do these tests that we do, and not just switch it on, do the tune-up, switch it off again and put it back. We never do more than one repair a day. We're supposed to have more than one test bench, but as you know, with building work ongoing here and with the organ and all that, we've only got one test bench set up. This is how I achieved doing more than one set, by having more than one test bench. So, we'll just go back to some of these figures. So, fill in some of these figures. Low power. So, let's just see what that is now. It's supposed to be 400 milliwatts. It is 400 milliwatts. I've put it on frequency. I'm just going to recheck that. 27.79145. So as everything's warmed up, that needs to come down a bit. .79128, so because they drop with age. Deviation we'll check with the other instrument behind me in case this one's lying. The RF meter, check what we've got. Helps if I go back to full power. It's now bang on the 4. I think we adjusted that together yesterday. S9 on the signal generator. Now we'll just adjust that. S9. Right, we're done. But it's probably taken more than an hour to do all that. So I just need to go over the back of the board with the isopropyl alcohol. And oh, that volume control's just noise I noticed. So I'm going to pause the video and do that and let it dry. Right, so I've done the volume control, hopefully. Yeah, it's on its own speaker. Of course, the other expense on this, we had to change those 2 cores in the transmitter. If you can look at the case, you can see it's certainly had a life. Right, let's have a flick round the channels. It's about 4 o'clock on Tuesday. We've also had a parcel today from our mystery benefactor Alan, so I'll look forward to opening that later on. I like to open those with Mr. Chippy, so when we're both available, that'll get opened. One down to Roger. $19 to Roger. There's no surprise there. Right, so we'll do an on-the-air test later on with Mr. Chippy. So quite a lot wrong with that Rotel 220. Thank you for watching.